Good morning or good afternoon or good evening to everybody who's attending today. We appreciate you stopping by and taking a listen to how both Franz and Expert System today are capable of applying semantic technology, particularly for business people. So we're going to try to keep to about 40 minutes and then entertain all the questions that we can handle. We are certainly willing to stay on longer if we go past the hour for those whose questions have not been answered. So let's look at the essential problem here as both Franz and Expert System understand it. That'll help set the stage for what it is that we're trying to set out today, and that is to look at the overwhelming amount of information. I've marked this as documents just because that's the predominant volume of information that we deal with every day in businesses, web pages and written materials and reports and emails and the rest of it. Of course, there's still plenty of material transactionally and in relational databases that goes understood, if you will. So the idea here is we face a very stark choice in this very simple diagram, which I literally finished about 2 minutes ago, is this stark choice between automation and a manual process or a manual way of trying to inject more understanding across the data sets, the documents that our businesses run on. Most of the pathways and most of the standards and most of the thinking these days has to do with setting out, if you will, to pump up the metadata around our documents with this new set of semantic standards are called RDF, RDFA. There's a whole bunch of standards these days. If you listen even to a Google of the world, they will tell you it would make an improvement in the way that the search goes forward, and yet they expect webmasters and other people in the IT community to literally manually take and mark up documents into an RDF format. And of course, this diagram is intended to show that that's a bit of a fool's errand. It will never scale. It will never have the speed. It will never have the accuracy that's intended. So our contention today is that this upper pathway, combining technology that can find and extract entities as well as relationships, placing those in a triple store rather than an endless list of RDF or XML, gets us to this notion of an ability to have precision and recall, so accuracy and completeness, as well as the ability to scale and do this at a high-speed rate. Because depending on your business, everyone has some both scale and speed issues in addition to improving what it is that we can get out of all the document sets that are a part of our lives. So when we look at this and do this collectively between both of our companies, and we do partner quite often, what we have discovered is that $1 invested returns about $400. As a simple mathematical ROI, everybody asks that question. On average, this is about what is the phenomenal ROI in pumping up or getting control over the amount of information running through our systems using semantic entity extraction and a semantic triple store to reason and build applications on top of. So that $400 is enhanced revenue, cost savings, or some combination of both. It's a tremendous payback. And here you see a list of the kinds of ways in which what we're going to present today get applied. You'll see some independent research from AMR, what it is that a line of business managers are looking to the IT community within their organizations to provide in terms of applications. So some of the most important are customer service, communication, PR, productivity, decision support, on down the line. You'll see, and we're happy to talk about some of the use cases with the logos you see against them in specific, and we can do that one-on-one with you at your convenience. So, all right. So let me tell you a little bit about entity extraction, and I want to show you both under the hood and in a slightly more polished way, and then we'll turn it over to Jans, and he's going to talk about the second half of what's going on in terms of taking the output of an entity extraction, put it in a triple store, and then reasoning across it to get great resolution, the precision, the recall, the speed, and the scale that I've already mentioned. So in expert systems case, we build our platform called Cogito. You'll hear Jans refer to it as Cogito. And so what is that? It's a machine that literally reads and understands. And we built that technology from the ground up to be to follow the same methods that we're taught to read and understand as children. And those methods are right there on the screen in front of you. They have fancy names, but they're very simple, and they're a build-up process in actuality. We don't think about it anymore, but back in the second grade, the teacher might have said something akin to, if you come across the word you don't understand, chunk it down. And that's morphology. What's the central part of the word? What's the stem of the word? To give us a clue what the word is meant to be about. And second is then to say, what is the role the words play? Sometimes you hear that referred to as a part of speech. So what's a noun, a verb, an adjective, an adverb? And then third, and again, this is the build-up process. If we know the first two, then we can begin a process of saying, okay, now we have a stem for every word. We know what role the word plays. Now, how do the words relate to one another? That's the logic. And what we're looking for there is this RDF subject, predicate, object. So it's boiling any sentence, any paragraph, any document down to its constituent parts. Who's doing what to whom? And then last is this most important idea of disambiguation. There's a mouthful, but basically it means, can we assign the correct meaning, the intended meaning from the author's perspective, to every word in a sentence, so there is no ambiguity. And of course, this is the essential problem in any language, is that almost all nouns and verbs have more than one meaning. You just crack open the dictionary, you can prove that to yourself. So, all right, so let's take a look at what that looks like quickly. Beg the forgiveness of any of you online, and I've seen some folks here today who have seen me do this before, but let's play with it a little. My car eats gas when I step on gas. So here's a little desktop application we write to give people a peek at the underlying technology. And what I'm going to do is ask the system to go through those four methods I just showed. And what you'll see on the right-hand side are some categories. So Cogito understands this sentence categorically, or think of it as a story arc. What is the totality of the information about? Down here you see the subject, predicates, and objects. The predicate eat is connected to the subject car, and then the car and eat are connected to gas. In other words, something eats. What is it that eats? My car eats. What does my car eat? It eats gas. So you see that. You see the parts of speech, nouns and adverbs and prepositions and all that. You see red and green sentences marked as a complex sentence. You see a group noun, a conjunction, and so on. So lots of intermediate steps, but then you would see the interesting part here, which is the disambiguation. So what we've done is assign this definition to the word gas as gasoline, and if you read the sentence, you can see that that is correct, versus this gas, which is the accelerator or the pedal, the gas pedal on the floor. Now it turns out, and you can see also that is correct. So it's a little bit of a game of trial and fit. So the thinking here, the system is actually trying on various definitions and understanding that eats in this context is to consume. So it's something akin to, well, you can't really eat a pedal, or you shouldn't, but you could consume or use up a fuel like gasoline. It's also noticing that car is here, so this form of gasoline probably connects with gas, as opposed to over here where what we're looking at here is you can't really step on a liquid, but you can step on this, which is a solid. Now the whole thing runs on the notion of a semantic network, which is every word in English, all the definitions of those things, and then here you see the connections between words. So for example, we see in this cut of the network, gasoline as a fuel is gasoline as an energy source is connected to fuel, and then to a more specific connection, which is premium gas. And there's more to the right and more to the left. You see that change as opposed to gas, as in air in the room, is a little bit different. So here's a material, then air or chemistry, and then a toxic gas. So it's a very complex network, but very, very rich, about 65 different ways in which words can be related to one another. Synonyms is the most common. We actually have, if you think back to your school days, we have a thesaurus, which is a one form of connection between words, and it actually turns out to be often a thesaurus is as thick as the dictionary. And so we literally built 65 different thesaurus. Think a different thesaurus for geography, words that are connected geographically, and so on. So lots of richness that allow us to categorize, establish semantic triples, understand parts of speech, and then get down to this notion of disambiguation. So, all right, so now let's also, let's also grab some real material and see where we go with that. So what I'm going to do is get some material here from the news today. I think Jans is going to talk a little bit about politicians and the oil spill. So let's grab some real material here and then get the entity extractions out of the system. And then, so I'm going to show you that broadly. And I also want you to appreciate how fast that went by. You'll see all that text and all these categories, politics, sport, and so on. Here are all the semantic triples, but mostly you'll also see every word disambiguated as well as extracted in terms of entity. So an entity here is understood to be a man, Charlie Crist, for example. Expressions are dealt with because of the semantic network as well. So it's not treating free of charge as three independent words. Understands an organization like U.S. Senate. Again, more phrases. You would also see Crist is consistently now understood to be a man, even though we don't have Charlie Crist. And so there's a great deal of interactivity. So from an entity extraction point of view, think 35 different versions or 35 different types of entities, people, places, things, dates, time, money, measurement, geography, holidays, URLs, et cetera, et cetera, et cetera. So a great deal of specification around all this material, and that gives us a working relationship across a working understanding both that we can use for precision in search or analysis as well as recall. So, all right, now let me show you a couple of simple ideas on how you might go ahead and use a system like this. And I'm going to do two things at once here before I shut up and let Jans talk. And that is to take note of the speed and scale issue, which I think is why we partner so well with Franz in this instance. So I can process in this little example here, let's pick on oil and gas again, take a feed of RSS news, and what you'll see go by on this bar down below is that we're fetching the first 10 RSS news feeds. Here comes the first, And as they could begin to go by, you begin to see the extractions of people, organizations, places, and they will build. But you'll notice that it goes by at a somewhat leisurely pace. And so architecturally, if you're in the technology realm, what you'll notice is it gets difficult to do this on the fly or in a real-time sense beyond a couple of dozen articles. So what happens, the best way to architect the whole thing is to be pre-processing these just behind what it is that you're trying to understand. But at the same time, that's one of the powers of the semantic web, the semantic standards, the semantic processing that we're talking about here today, in that what's interesting and powerful and important is often not just within one document, but it's the connections across documents. And so constantly processing and understanding that information gives us a chance to connect it, understand it, and then diagram it, as you'll begin to see in Jan's much richer way of doing that. You'll see here, we've done it in a very simple fashion here, in the ways in which organizations, people, places, actions, etc., are connected to one another. Again, not just within any one document, email, or web page, but across many of them. So I'll leave it there for now. Now, one other thing that we do want to offer up to everybody is this notion of, a bit of a playground, if you will, after this. Please be in contact with us. We can give you a web service. You see some of it here. That will allow you to begin to process and receive back XML, RDF markup across the content, and Franz will be able to give you their triple store and reasoning algorithms to transverse that RDF and make sense out of it. And you'll be, sorry, this is just an extra demo. So we welcome the invitation to try out exactly what you're seeing here today, and be sure to ask us about that. Okay, that brings us to just about 1:20. Steve, can you switch us back and let Jans take over, please?
Okay, thank you, Brooke, for the nice presentation. Jans, I'm going to be making you the presenter. Okay, now you just need to show your screen. Jans, you there?
Yes, I'm here.
Okay, you've got the stage.
Okay, so Brooke, thanks for introducing us to the wonders of entity extraction. And what I'm now going to show you is how we at Franz use Cogito to extract entities from any kind of text and put it into a triple store and then do advanced analysis on those triples. And for an application that I'll show you today is something where I track politicians in the news. And actually I'm preparing another talk, a webinar, where we'll only talk about this application, do all kinds of analysis on the text. But today I'll just focus on the combination of an entity extractor and a triple store. Now, we sent out an invitation to both the people interested in triple stores, but also to the people interested in the Cogito product. So there will probably be some people in the audience that don't know what a triple store exactly is, and it's not the time to give you a full introduction. Let's just say that it's a database where you don't have to make schemas, where you can just say whatever you want to say as long as what you say is a triple. So you could have a triple Jans is a man, that would be a triple. And what we can do with AllegroGraph is literally store billions and billions of these triples and index them in such a way that you can get any triple back very quickly. And at the end of the year, well, we're on a contract where at the end of the year we have to deliver a triple store, a distributed triple store, where we actually have to go to 1 trillion triples. So we're scalable and persistent triple store. We do federation. So you can have multiple triple stores, and then you hook them up together through an abstraction, and then you can talk to that federation. We do all the RDF standards. We are a little bit like a hybrid between a relational database and a triple store in that we also do range queries on numbers, dates, and telephone numbers very, very efficiently. And we specialize in event handling with triples. So, and given that events always happen in a particular place, we do spatial database functionality. We can reason about time, and we have extensive social network analysis libraries. And if you want to know more about that, we have a few presentations on our website where you can get presentations like this webinar and get yourself familiar with those. And then one final thing about AllegroGraph, and then I won't talk about it anymore. But 3 weeks ago, we came out with AllegroGraph 4.0, and AllegroGraph is now a completely transactional system. It's ACID. We do commits and rollbacks. It's now 100% read concurrent database. We provide all the database functionalities that you want to have in the enterprise. So we do backups and replication. And well, it's just so it's an ordinary database, except that we store triples. But let's go to the main part of my presentation, and that is tracking politicians with a triple store and an entity extraction. So just imagine you would have to do queries like this. Say you wanted to use Google or Bing, and you want to say, hey, give me all the newspaper text that have both a Republican and a Democrat that serve on 2 different subcommittees that have the same parent committee. Yeah, it would be really hard to write a Google query that will give you that back, because Google and Bing give you just keywords, but no meaning, no relationships between words. You could say, well, which Democrat or Republican is most vocal in the oil spill disaster? And in a search engine, you would have to kind of do this in multiple steps and actually search for particular Democrats and Republicans. But in a semantic system, you can analyze text, and then you have people, and you know for a particular person what type that person is or what the role of this person, and then suddenly you can do queries that you could not do before. And so I've got a bunch of other queries here that you can't do, and in one of my upcoming talks I will actually go through all these particular queries and show how you do that with the triple store. But let's now focus on the triples again in the entity extraction. So what we do is we spider daily more than 300 online newspapers and thousands of blogs. And then what we do, we've written our own in-house spider, but there are actually now spiders on the market like AT Legs that will give you open source spiders, make it very easy to spider websites. And what we do is in each page that we spider, we look specifically for members of the Senate and the House of Representatives and the executive branch. And then for each of those that we find, we apply cogito to the text and extract the main concept, just like Brooke just showed you. And so what we get is per text roughly about 150 triples, 150 to, well, 300 I would say. And so we get about 500,000 triples a day. And so that's what we get from the news, but we also have a whole bunch of other databases that we then hook up to this news data. One of them is a detailed database of each politician in the United States. All that information is publicly available. It took us about a day of work, and now we have an RDF triple store with all these politicians available. And I'll show you why that is so useful to have that. So, well, here's some pictures. So what we do is we go, for example, to the Huffington Post. We see some, there's a section with politics, and then we go to each of these articles and we get this particular text, and then like Brooke showed before, we take out this particular text out of our scrape, and then we make a whole bunch of triples. So when we apply cogito, one thing that we get out of there is the people. So we get triples of the form text1 has person Obama, yeah, and then we take places out of a text. So we get a triple like text1 has place Washington, or we get an organization it's IBM or State Department. Then what Cogito also does, it kind of gives you the main categories of the text. So I could say text 1 has domain politics. And then there's a whole bunch of other words that are interesting or relationships, and we turn these into triples too. And we call this as the predicate for these triples has main groups. And so I'm going to give you a demo of how this works. I will show you how we look at the main properties of a text, how we use full text indexing to get to particular topics. I will show you some SPARQL and Prolog queries. By the way, for the people that only know about entity extraction, SPARQL is the a new standard for doing queries over RDF and semantic entities. And I'll give you a simple demo. Again, this is not a webinar to teach you SPARQL, it just gives you some examples. I will also show you how I can take one particular article and then find all the other articles that look like that one based on the semantic content of these papers. And then finally show you how to automatically find connections between two texts. And then what I told you before, what we also do is hook up to other databases. I won't go in too much today about what we do there, but what you see here is a cloud of about 20 billion triples that are published on the web. For example, you have here DBpedia, which is the RDF version or the triple version of the Wikipedia. There's a database called GeoNames, which has about 7 million places on Earth. Each place with a latitude, longitude, what kind of place it is, the population, elevation, etc. And again, all in triples. And we hook up specifically to Freebase to get the names of companies and then extra information about companies, and then we hook up to DBpedia and GeoNames. Okay, let me start with the demo. So the first thing I'm going to show you is, so I've taken all these texts, I applied Cogito, I got a whole bunch of triples, 500,000 triples. So I'm going to give a demo about 1 day of scraping the news. And then a typical query that I can do and that I will start with is, give me a newspaper text with a Republican and a Democrat that serve on two subcommittees that have the same parent committee. Yeah, so let me go to the demo. No, not that one. So here is what you see here is Graph, which is our visual interface to our triple store. I'm going to do a query. And so is the particular query, I've done it before, so I will change it in a second. And so here is this query that is identical to the English query that I just showed you. So I say, give me a text that has a government person P1, and this text also has a title, and this person 1 is a Democrat, and the text has the person 2 who is a Republican, and then person 1 is on subcommittee sub 1 and P2 is on the committee sub 2, and these two committees sub 1 and sub 2 have both the same parent here. And then give me, say, the first 3 of these people. And so what you see here is the results of this query on about 500,000 triples. Let me go back to 2. And then, so I have these results, just like in a relational database, select star from, except the star in a triple star means give me all the variables that you saw in the query itself. I can create a visual graph from these results. And so here you see the politician Cliff Stearns and Bruce Bailey, and here you see the committees that they're on. So they're on so for example, Cliff Stearns is on the current committee, so the blue line. So if you see here, the blue line on the left is the predicate for committees. And then you see here the subcommittee that he's on, and this subcommittee has a particular parent. And this parent is in the House Committee on Energy and Commerce. Yeah. So let me click on a particular, well, let me click on this particular person. And so here you see all the triples that we had. So as I mentioned, we had a triple store with detailed information about politicians. So Bruce Bailey comes from this particular state. He's on these 4 committees. First elected in office is around this time. Here you see the same committee that you see here, except I have some additional information, like he's number 23 in this particular committee. By the way, I could click on this committee here, and then I see all the people that are actually on the particular health committee. But let me go back again. He's a male. So from a triple store perspective, you have to read it like this. Bruce Bailey has education, law degree, University of Iowa. Yeah, so this is, for example, one triple that we display here in this particular format. And then here you see all the text for the particular day that he appeared in. And so I could click on the particular text. And then in this text, we see all the stuff that Cogito added to this particular text. So, for example, Cogito told us that this text is about commerce, about a company, about a database, and economics. Here are some important words that they found in the text. For example, Hamilton County resident and housing authority, low-income housing. By the way, if I clicked on this, I would, there's only one text that day about low-income housing. It found the people in the text, and but of these people, only one was a government person, so this is the link back to Bruce Bailey. And then here you see relevance, because what Cogito also does, it's for every word. So for example, you have the word tenant, and then you can see how important tenant was in this particular article, which was probably 3, so it's not a very important word in this text. Yeah, so let me go back to the graph view. And so we've seen the triples for a particular person. We've seen a triple for a particular text. But I can do some other queries. So I'll hit the letter W, and I could say, well, let me find a query where I want to find articles that resemble another article. So say I'm interested, so what you see now is the prologue query. And we wrote a stored procedure called close to articles, where we say give me all the articles that resemble text 60 based on these 4 predicates. So each of these predicates were actually created by Cogito. Yeah? So we have text 60, and then we say we want texts that are roughly the same, but based on the domains that we have, the main groups, the people, and the places. Give me the 10, and then for each article that we find, give me the title of the article. So then we do evaluate, and then we find that text 60 has 18 things with itself in common. Basically, it means that these 4 Cogito predicates have 18 values, and the title is Fund Manager Battles Over For-Profit Colleges. The next text that looks like this is text 2421. It's also about for-profit colleges, etc., etc. Yeah. And then I can create a visual graph of this again. And so now we see all these texts, and yeah, this is probably not a good idea over GoToWebinar. Now I could say, hey, I'm really interested to find a link between this text and this text. So I could say, well, I hit the letter I now, and I see all the predicates that connect things together. So I could say, well, I was interested in the people, the places, the organizations, and the domains. And then I can ask the system to automatically find a link between these 2. And then you see, so this text was related to this text through Iowa, Commerce, Finance, and Economics. We could say for this one here. And so we could automatically link texts to a particular text. And then, of course, I could look at particular people. So I could find, say, a random person, a politician. So I go to a person, and I have no idea whether this person is related anyway. So I could say, well, is there a relationship between this particular person and this particular text? and I find that there's 145 text paths that will connect me from this particular person to this particular text. And again, I could find some links. And I find the links between Ike Skelton and this particular text. So that is roughly what I wanted to say about how we work with Cogito to use their technology to get triples into our triple store. Again, there's a whole bunch of analysis that you can do on this text that is more interesting to if you study political sciences or you're a journalist or a politician. And I'll do a separate webinar on this, but I would propose that we open the floor now for questions. So Steve, do you want to take over, or do you want us to look at the questions?
Okay, thank you, Jans. There's a few that have been queued up, and anybody else can enter their questions. Brooke, I think there's a couple that were from you, but I think you've answered the first one about the disambiguator being available for download somewhere and that you're providing a service. Then there's a comment and a question. Very impressive database of words. Can it be customized?
Yes, that's right. And so my answer there was this very typical request, and the answer is yes. We start with a common dictionary of all of English, but often we need to enhance or adjust or take account of special lingo, let's say, within an industry. For example, we have enhanced the semantic network to account for the categories used in publishing called the IPTC, and it's a standard way of understanding what a news article, what bucket a news article ought to go into. So we've directly edited and enhanced the semantic network for that. We've done another for the oil and gas industry, for pharmaceuticals, etc. So yes, and outside of doing that directly, like AllegroGraph, there are development environment that comes with the Cogito platform that allows you to write additional rules. Jans has done some of that himself to do the demonstration you see here today that can, as a backdoor way of enhancing how the algorithms work. So there's a couple of different avenues to get the customizations through.
Okay, thank you. And there's an RDF question for Jans. What is SPOG&I? I think it's on the index.
Oh, so we have a triple consists of a subject, predicate, object. So if you have Brooke is a man, then Brooke would be the subject, is a would be the predicate, and man would be the O, the object. And then people use a fourth argument. So a triple usually has 4 parts. It's just a, well, let's not go there today. So the fourth element is used to cluster triples. So you could, for example, have a whole definition of Brooke, let's say 20 triples describing Brooke in a particular file. You could use the file name as the fourth argument so that you could very easily say, give me all the triples from this particular file, delete all the triples from this file, or do my reasoning with this particular area. So it's a fourth argument, the G, and then we have the I, which is the identifier of the triple. So in AllegroGraph, you have every triple has a unique ID, so that you can actually use that for arrayification. So you could say Brooke is a man, and that could be triple number 1, and then you could have another triple saying every person believes triple 1. So now I've said something. Now I've got one triple saying something about another triple.
Okay, yeah, and so G is the named graph.
The named graph, yes.
Okay, Brooke, there's another question about Cogito. How well does it perform when the text does not have a well-formed prose, such as bullets in a presentation slide deck?
Right, yeah, we have to do some engineering around, oddly formed things, but we have worked very hard to understand the general format of material that is most commonly used. So a PDF document, a PowerPoint document, even relational databases, spreadsheets, and the like. They all contain some form of unstructured information. It's harder if the information is written in shorthand or with a lot of acronyms and the like. But again, that's why we have the development environment that allows our staff of professional linguists to study the material and how often that kind of format is being repeated, and write additional algorithms to take account of either the format or say even an acronym that's unique to an individual company, which is far more common than you would think.
Okay, and another question for you, Brooke. Are the relations extracted from Cogito, such as has people, has places, etc., part of an ontology that can be used to perform some sort of reasoning?
Yes, that's exactly what Jans has been showing you. So that's why we fit together so well. We do the basic markup across the material. Again, with the development environment, you could declare the relationship, call it anything you like, as long as then the reasoner in the form of AllegroGraph can say consistently, this is the relationship between a person and a thing, and then you can make those inferences across vast amounts of information. So, you know, what we've looked at here today is certainly relationship between politicians, but you could turn the whole thing on its head and use different kinds of relationships, let's say between criminals and money, or terrorists and methods of actions, or terrorists and other organizations, or fundraising. You can do it in the business world for modeling, you know, and creating early warning signals around pending technologies or products or mergers and acquisitions, and all kinds of really interesting things that if we step back and look at the world, the overwhelming amount of information that's all around us, and start to ask questions like, what does it mean, and what could I do with that information if I could only get my arms around it? And you begin to get some very interesting answers, like maybe my company could have some degrees of freedom to act prior to my competition. If I knew what pending legislation might do, or what the form of pending legislation would look like, with a high degree of probability, and I knew that before anybody else, I could certainly take account of it. The same with my competition, the same with technology and products, and etc. So law enforcement thinks this way, businesses think this way, and so what the two of us are capable of doing, between extracting the entities and providing reasoning over that, is to repurpose and add value to information that is currently, really, honestly, going unused within the organization.
Okay, thank you. There's still some more here. How do you choose the websites for the spider? Are there any limitations or advices from the technology point of view, like the technologies the website are built with, or just a content-based choice?
I did an analysis of Google News and Bing of news. So the first thing is, I just thought, okay, let's just scrape Google News and Bing, but it took me about less than 10 minutes, and Google News totally shut me out from spidering, so I had to try later and do it a little bit slower, because somehow Google is allowed to scrape everything under the sun, but if you try to scrape Google News, then there seem to be some restrictions. But anyway, so I did an analysis, and I found if you look at political articles and an available online newspaper. So I got an ordering, and I got about 300 that every day have at least some articles about it. If you're interested, by the way, just send me an email, and I will send you the list of all the websites that I'm spidering.
I could offer a little bit on that as well. What I'm thinking is not the technical hurdles. Sometimes some sites are harder to spider than others, but I think it helps a great deal in using this kind of technology to be judicious in what you want to send through it. So picking sites that have a good deal of fact checking and editing behind them, it just makes the processing resonate better, and the results are better rather than sort of throwing everything under the sun through it. The opposite of that, however, it can get very interesting if you wanted to think from a social media perspective. What are people doing and thinking and feeling and so forth across 10,000 tweets or something. That's a different sort of animal, and it can be done. It's just what the outcome of it is a little bit different. The purpose and the outcome is a little bit different.
Okay. This is about the thesaurus. Is the oil and gas thesaurus available for use, say, as a product or software as a service?
Yes, it is. We did that on our own volition or have permission from customers who paid us to do it. In other cases, customers ask for customizations and put us under restriction because it really becomes their intellectual property. So we can happy to discuss where that begins and ends, one-on-one. Happy to do that.
Okay. Also, does Cogito work with languages other than English?
Yes, it does. German, French, Arabic, Farsi, Italian. We've begun work on Chinese, simplified Chinese. Not every language under the sun. It is not statistically based. It is linguistically based. So building the semantic network has to be done for every language. You can appreciate that it's difficult work, but it's really the secret sauce that gives us the kind of precision out of the box, which is about 80%, by the way, and then supplementing that for each customer gets us over the 90% precision and recall mark. That's always our goal. But doing it for individual languages is both important, but it's difficult. Of course, if it was easy, everybody would have done it already. So, and in English, by the way, 350,000 words turn into almost 3 million different kinds of relationships. So words and definitions are easy. It's building the pathways between words that's difficult.
Okay. Are there any COTS enterprise search or text analytics products that you integrate with?
Yes, good question. Thank you. I think we have done this with FAST as a standard enterprise search product. We've done it with SharePoint, another collaborative, popular enterprise collaboration environment, and probably a few others that I'm not aware of at the moment. But these are very standard kinds of ways of doing integration, and then getting an enhanced return on investment on a sunk a product with a sunk investment already. So it's just sort of in the background enhancing the value, the semantic understanding across all the content is a really good way of using this kind of technology.
Okay, here's one about triples, Jans. Can you set thresholds about the number of triples and or the certainty of the triples that are extracted from a document?
Yeah, so there's various ways to answer this. One of the things is that out of Cogito you get an estimate of how important a particular concept is in the text. And so I use that, for example, already to not to take all the things that I get from Cogito, but only things that score higher than a particular value. Yeah, that's yeah. Basically, that is the main thing I do now to set the number of triples. I actually also store the relevance of the concepts in the triple store, but given that I already have so much data, and you only use it at the input time, I'm kind of thinking of leaving them out in the triple store itself. Only use them at the begin time, but then just leave them out in the triple store. But yeah, you can. Well, you're completely in control what you get in there or not.
Okay, so here's another one. There's more coming. Is it possible to apply an upper-level ontology, such as OpenCite, to increase reasoning conclusions?
Yeah. I usually give another demo. This is where I take any kind of text, and then in the text I look for scientists. Because I hook up to the DBpedia, and the DBpedia has included the Psych database. And so many people are there, have the annotation of their role couched in WordNet and in Psych, and so I can search for all the scientists basically based on the Psych ontology.
Okay,
and I'm also thinking, yeah?
Go ahead.
No, you go ahead.
Do predicates come only from the text, or can they be reasoned using rules? For example, can a person's name be recognized as the author of a document even if words do not explicitly state person is author?
Let me start with that one, Jans.
Okay.
Again, in our development environment, this is one of the essential components of building robust entity extraction is the idea that a linguist, or even in the hands of a programmer, can use the tool set to study the material, study the corpus, and look at it and say there's enough material here to indicate a person is an author without ever saying person is author. So John wrote, John said, etc. So there's a great deal of variety in the way in which authorship might be expressed, and so we want to write additional rules which will trigger markup that put John, assign John as an author to a variable that becomes part of the RDF markup that then goes into Franz.
Okay, here's one. Do you have an Apache UIMA interface that is a pair file that we can plug into our linguistic pipeline?
Jan, do you want to handle that one?
Well, it's actually a question for you, because the UIMA is open source. I think it's the open source.
Sorry, right. This is the right. Isn't this the IBM standard, right? Yeah, actually, we do adhere to the UIMA standard. It's the pair file that threw me off. I'm not as deeply technical on that side as I could be, but I do like the idea of pipeline. I mean, when I said earlier we integrate with FAST, we do that in the pipeline architecture. So as for example, as someone authors a document, I think this is probably what you're getting at, Dan. If someone is typing a document or finished authoring a document, can we interject ourselves, sort of hijack the content as part of the pipeline, mark it up, and then return it back to the pipeline so that the rest of the technology further downstream can take advantage of that? And so the answer is yes. We can take the regular stuff, the regular content, mark it up, but then adhere to a markup format that subsequent technology further down the pipeline can take advantage of. Good. I see.
Okay.
I've answered you correctly, Dan.
So will these products have a web accessible APIs, and also is Gruff available for download?
So Graph is a free tool. So well, you can just go to our website and then download Graph. It works on all platforms. If you want to work with 4.0, then you have to work on Linux right now. But that even works. But you can just go there and grab it. I sometimes make some of these demos available by Triple. Let me think about whether I'm going to do this for, say, 1 day of scraping for, so you can just take that and download and do the demo that I did today. So you don't have to go through the entity extraction, but just get the result of a scrape and application of entity extraction, and you could play with the data files. Let me think if I can do that. That would be an interesting. We would send it out in the newsletter if you make that available.
And the other part, will these products have web accessible APIs?
Well, you already saw that Brooke showed you can give you a demo link or a link where you can use HTTP protocol to send a text to the URL and get the XML back. 4.0 is totally REST-based, except we don't have an installation somewhere where people can just go to the Triple store. But it's something that definitely will come.
Yeah, that's right. And what we can send to everybody is the web service to go ahead and send your text and get the markup back. But what we'll include there is an API documentation. So there are a lot of different calls and responses that you can engineer, as a little sample demonstration around. That's fine with us.
Okay, we're running out of time. It's 11. I'll look at this next one. Brooke, you said Cogito integrates with FAST, and the person's asking that's probably FAST ESP. What about the new FAST for SharePoint?
Right, yes, you're correct. It's FAST ESP, and we're looking at the FAST for SharePoint. Our engineering team is tearing into that to see if it's, a major difference or a minor difference. I don't know the details under that yet, but we are working on it actively.
Okay, well, this is a great bunch of questions, and I'm sure I didn't get to all of them, but we will entertain questions by email. So if there's any final comments from you, Jans or Brooke?
No, we really appreciate everybody's great thinking and great questions. We welcome any further questions or one-on-one conversations. Happy to entertain those. Okay.
Well, great presentation, guys. I'm going to end the meeting now, so I'd like to say goodbye for now. We'll see you next time.
Thank you, everybody.
Thank you.